Right, the only other concept that I want to talk through is the idea of classifying triangles based on the lengths of their sides. Okay, so we can see that if you take the sum of the squares of the smaller two sides, and you compare that to the square of the longest side, okay, you're going to be able to identify or classify the triangle. You'll determine if they are equal to each other. We just saw that in Pythagorean theorem, that the sum of the squares of the two smaller sides is equal to the square of the longest side. You have a right triangle. Okay, however, if the square of the longest side is greater than it would have been in a right triangle, or greater than the sum of the squares of the two smaller sides, you're dealing with an obtuse triangle. If the square of the longest side is smaller than what it was in a right triangle, meaning that the sum of the squares of the two smaller sides is greater than the square of the longest side, you're dealing with an acute triangle. Okay, let me kind of talk through this here, or demonstrate it in Sketchpad really quickly, okay, to confirm what's happening. Okay, so if we take this triangle right here, this is a right triangle that I begin with. Okay, so side J is 2.7, side K is 4.8, side L 5.53. If we take the sum of the squares of the two smaller sides, compare it to the square of the longest side, what you wind up seeing is that they are equal to each other. Okay, now, what would happen if we took these two smaller sides and we left them the same? So they're still, I'm just going to place it on this circle so that distance J and distance K are still the same. But what kind of a triangle am I looking at now? Now it's obtuse, right? So let's see if that's confirmed with this relationship. So if I measure this new side, okay, and then I square that value, okay, how does this now compare to the sum of the squares of the two smaller sides, which still make up the two sides of that triangle? The longest side squared is greater than the sum of the squares of the two smaller sides, so what kind of a triangle are we looking at? Obtuse. And let's take a third example. Okay, we'll still place this so that the sides J and K are exactly the same. And let's create this new triangle. What kind of classification is this new triangle here? It's an acute triangle, so let's take a look and see, again, this length here. We find that measure, and we square it. We now have the longest side squared is now smaller than the sum of the squares of the two other sides, the two smaller sides. And so what you have is you have an acute triangle. Okay, but these three rules come into play. Okay, so if we were going to take an example of this, okay, classify the triangle based on these three sides. Right, what kind of a triangle are you dealing with if those are the three sides of your triangle? So the answer is acute. Okay, if you take the sum of the squares of the two smaller sides, are they written in order from smallest? No, so don't just move from left to right. Take the sum of the squares of the two smaller sides, and you're going to compare that to the square of the longest side. So you get 16 plus 36 compared to 49. When you look at the relationship here, 52 is greater than 49. So again, what you think of, and I always reference the longest side. So if you think the longest side squared is less than or smaller than it would have been in a right triangle, so here's the right triangle, it's smaller than that, so you're looking at an acute triangle.